Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. To work out the mass, we will need to find the density and the volume. Density is given to us in the question, but volume isn't, so we need to work out what the volume of this cuboid is. So the volume is just the 33 times the 7 times the 22. So that would be 5,082, and that would be centimetres cubed. And we need to write down the formula for density. So density is the mass divided by the volume. So rearrange this to get mass on its own, because that's the thing we're looking for. So mass equals density times volume. Density is given to us in the question as 2.1 grams per centimetres cubed. Times that by the 5,082 for the volume, and we get the answer of 10,672. And then that will give us grams, because our density is in grams, so that is grams, but the answer is asking for kilograms. So to convert that to kilograms, we just divide by 1,000 and we get 10.672. Then we need to round that to 2 decimal places, and so that would be 10.67 kilograms. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 9007000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half A plus B times H, and A and B are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half A plus B H. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack. So we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. There's a few different methods to find product of prime factors, but I prefer using the bubble method. So we put a circle around 75 and we want to split it up into 2 numbers, so 2 numbers that multiply together to make it. I always pick the smallest that I can think of, which is normally 2, but in this occasion the easiest one for me would be 5. I think also 3 goes into it, but 5 to me seems nice and easy. It doesn't always have to be the smallest that I pick. So 5 times what is 75? Well, 5 times 15 is 75. And then to make 15, we're going to do 3 times 5. And the reason why I've done some of these bubbles in red is that those are the prime factors, which means they can go to 1 and 5. But if you do 1 and 5, you'll be there all day. So we always stop when we do the prime numbers. And so we're going to write these in a list. So 3, 5, and 5. The product means that we put a times sign between them. But if you notice here, we've got 5 times 5. So a different way of writing that in index form is 5 squared. So our answer will be 3 times 5 squared. So we're given 21 to 4 is the ratio. And we're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay. And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. So to find the gradient, we need the formula or the equation in the form y equals mx plus c, and the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first, just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6, because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. When translating, we translate with vectors, and the top number in a vector tells us how far right, and the bottom number tells us how far up we go. And to translate a shape, you always pick a point. Now I always pick the top leftmost point, so I'm going to pick this one. And looking at the vector, it says we're going to go 2 to the right. So we do 2 jumps to the right, 1, 2. Now looking at the bottom, because it's minus 4, instead of going up 4, we're going to go down 4. So it would be 1, 2, 3, 4. So our new coordinate for the top will be here. And the next thing we need to do is draw in the shape. So that's the top left part of the shape. And so I'm going to draw in the shape, and it's 4 across. So it should go here. And draw in the shape in there. Make sure that you know that that coordinate is the top left part of our shape. And it says to label it B. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. So the distance initially travelled is going to be 14 kilometres for this stint here. And then we have a bit of a rest. A horizontal and distance time graph is essentially stopped. But then here we start up again to go home. And so that's another 14 kilometres travelled. So in total there has been 28 kilometres travelled. To find the mean, we need to work out the sum of the numbers, basically what they add up to. And what we then do is divide that by the amount of numbers. Now, what this table is telling us is there are 14 students who got a time between 0 and 4 seconds. Now, it's absolutely impossible to work out what time those students got with the information in this table. So what we need to do is we need to assume they all got, say, 0 seconds or all got 4 seconds. And the fairest value to say that they all got is what we call the midpoint. And to find the midpoint, what you do is you add up the lower bound and the upper bound, so the highest value and the lowest value, add them together and divide by 2. So 0 plus 4 divided by 2, which is just 2. And that gives us a halfway number, which is fair to everyone. So the students roughly probably got 1s, 2s and 3s, and maybe a few 4s maybe. And the average of that is going to be 2, so that's fair for everyone. Same with the 4 and the 8. Halfway between 4 and 8 is 6, and you can add them together, 12 divided by 2, which is 6. Go down finding the midpoints, and we're just going to assume the students all scored the same amount, all got the same time. Then we're going to do our FS column, okay? And so we're assuming that 14 students got a time of 2 seconds. So when you times those together, you get 28. And we're just going to times all of these together. Okay, next we're going to work out the sum of the FS. And to work that out, we just add all of these up together. So we're going to do 28 plus 36 plus 30 plus 126 plus 36. And when you add them all up, you get 256. Now, that will give us the sum of numbers. So we're going to put that into our working out now. And we need to find out how many numbers there are. Well, the frequency column will tell us how many numbers there are. So we're just going to add all of those up together. So we're going to find the sum of the frequency, which is 14 plus 6 plus 3 plus 9 plus 2, which is 34. And when we do 256 divided by 34, we get 7.529 blah blah blah. It says it wants it to 2 decimal places, so we're going to round it to 7.53. Whenever we solve, we've got to get rid of any fractions or brackets first. Now, looking at this, there's no fractions, but there are 2 sets of brackets. We've got the set of brackets here, and we've got the set of brackets here. So we're going to expand them to get rid of them. And you can use any method you want. I'm just going to use this kind of grid method. So we're doing 4 times, and inside the brackets we've got 3x plus 5. So I'm going to times those out. 4 times 3 is 12, so that'll be 12x. 4 times 5 is 20, so that's going to be positive 20. And I'm going to do the same for the other set of brackets. Now on the outside of the brackets we've got to be careful here. It's not a 5, it's a minus 5. And inside the brackets is an x and a 2. So minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. So when we put it all together, we get 12x plus 20 minus 5x minus 10. And then the rest of it is just equals 52. So I'm going to start by putting my lines in because we're solving. And I'm actually just going to start by collecting the like terms on the left hand side. So 12x take away 5x is going to be 7x. And 20 take away 10 is going to be 10. Okay, now we need to get rid of the plus 10. So we're going to take away 10 both sides. So we've got 7x equals 42. And then we need to get rid of the times 7. So we're going to divide 7 both sides. So x equals 6. So we're going to start off with x equals 0, and we're going to write out this equation but with 0 every time it says x. So it's going to be y equals 0 squared minus 0 plus 10. Well, 0 squared is just 0, so 0 take away 0 is just 0, plus 10 is just going to be 10. So the answer there will be 10. Do the same for 1. So it will be 1 squared minus 1 plus 10. Well, 1 squared is 1, 1 take away 1 is 0, plus 10 is 10, so that will also be 10. 2 squared minus 2 plus 10. 2 squared is 4, 4 take away 2 is 2, plus 10 will be 12. Now we're going to do the negative, so we're going to look at minus 1. So it's y equals minus 1 squared, and it's going to be minus 1 plus 10. So a little bit more complicated here. Minus 1 squared is just 1. Now here you have 2 negatives together. When you have 2 negatives together, it makes a plus. So we've got 1 plus 1 plus 10, which is going to be 12. And then we'll do the minus 2. So it'd be minus 2 squared minus 2 plus 10. So minus 2 squared is 4. The 2 minuses here make a plus. So it'd be plus 2. Should be 6, plus 10 will be 16. So we're going to plot these on our graph. And so we've got minus 2 is at 16, so that'll be there. Minus 1 is at 12, should be here. 0 is at 10, 1 is at 10, and 2 is at 12. Okay, when you join this up, things to be aware of is you need to make sure that you have a round U at the bottom and not a flat bottom. Okay, so you want to avoid a flat bottom. You also want to make sure that you avoid feathering like that. You want just one nice smooth line, and my recommendation is always to turn the page on its side. I don't have that luxury, so I'm going to try my best with this, but you need to make sure it goes through all the points, and here's the part here where it goes beneath those 2 points, so make sure it goes beneath those 2 points. On most exams I see them, basically what they do is they draw a line across from those 2 points and say that the line needs to go beneath that, or your curve needs to go beneath that line. So they're looking out that you've gone beneath the line. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the 2 parallel sides here, which just pick a different colour, here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles, so that's what we've got here. So the area would be half times a, which is 28, plus b, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14, therefore the radius would be half of that, which is 7, and the area of a circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now I'll keep that in my calculator, because next thing we'll do is the shaded area part, and it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93 blah blah blah, and when you do that you get 140.061 blah blah blah. It says it wants it to 2 decimal places, so it would be 140.06. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other 2 in a right angled triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it would be 49 squared plus b squared equals 68 squared. And 49 squared is 2401. And 68 squared is 4624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2401 from both sides. So we've got b squared equals 2223. Then we're going to square root both sides, and we've got b equal to 47.148 blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it would be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148, we've just worked that out, and we're looking for c. In fact we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to x squared, and we just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants its two decimal places, so that will be 61.19. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1, 25, and 5, and 5, and the factors of 35, which will be 1 and 35, and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6. And so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So here we're asked to factorise a quadratic, and our answer will be x plus or minus something, x plus or minus something. So it'll be 2 sets of brackets with an x at the start. Okay, so to be able to find out what's in the bracket, we look at the 36 there, and we know that we're going to have to multiply 2 numbers together to make that 36. And we look at the coefficient of the x, that 15, and we know we're going to have to add these numbers together to make that 15. Now, if you just can figure out in your head the answer, that's absolutely fine. If not, you can just quickly write down the factors of 36. Now, because they multiply together to make a positive 36, they'll either both be positive or both be negative, but they add together to make a positive number. So we're just looking at the positive factors. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And we're looking for which ones of those add together to make 15. And we can see here it's going to be 3 and 12 add together to make 15. So our two numbers are going to be plus 3 and plus 12, or the other way around. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10. 990. Now when we're looking at limits with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. Something we know about rectangles is opposite sides are equal, so these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, and the s in same is the s in subtract. So we're going to subtract going downwards. We're just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I can pick the 2x plus 3y equals 41, and just substitute the value of x in. So 2 times, instead of x, it's times 10, plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21. And then we're going to divide by 3 both sides, if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93. So we know we've got it right. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out. And we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around, up until this point, is 270, because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. Okay, so we're going to start off by working out the multiplier, and we're told, we always start off with 100%, we're told that the compound interest rate is 1.6%, so we're going to add 1.6% to the 100%, and it's going to be 101.6%. Okay, make that into a decimal by dividing it by 100, so we're just going to divide that by 100, and this will give us the decimal or the multiplier. So the multiplier is 1.016, and so anytime we want to increase something by 1.6%, we just times it by 1.016. Now, we're told that we start off with 2,400, that's our original amount, and to find out what it's going to be in the savings account at the end of the first year, we just times it by the multiplier, 1.016. But we're told that it's for 7 years that it's going to be in there. So we then times it by 1.0167 times, or easier way of doing it is 1.016 to the power of 7. When we do that, we get 2,682.052 blah blah blah. And because it's money, we round to the nearest pence, so 2,682.05. To find the median, we need to first of all find out what the highest cumulative frequency is. So it's 20 altogether, 20 rocks altogether. And then we halve that. So we go to the 10 here. And all we need to do is draw a line across from 10. And stop where it hits the line. And draw a line down from there. And that to me is roughly, what is it, about 17. Because the axis is going up in 2s, and so it means the median is 17. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements, so what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet, but they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. We're going to times top and bottom by 3. And so it would be 3 brackets k plus 1 over 45. And the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together. And I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4, and then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k, and then 3 plus 4, which is just 7, over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. Okay, so first thing I'm going to do is just a quick sketch of this diagram. So we're told the lengths are 8 and 6, and the angle between the lengths is 64 degrees. And we've kind of got a missing length down here which we need to find. So we need to find that one. Okay, so let's label them. Now we're going to be using the cosine formula. So cosine formula involves angle A. So we're going to label the angle A. And the one opposite, the one we label as A, is going to be little a. And then little b and little c, it doesn't matter. Right? It doesn't matter which way around you do them. So we're going to write down the cosine formula. So it's a squared equals b squared plus c squared minus 2bc cos a. And so that would be x squared equals, and that will be 8 squared plus 6 squared minus 2 times 8 times 6 times cos 64. And that will be x squared equals 57.916 blah blah blah. And we just need to solve this, and we can solve it by just square rooting both sides. So it would be x equals 7.61000 blah blah blah. Okay, we're asked for the perimeter, and so we need to do 8 plus 6 plus that 7.610 blah blah blah. I've still got on my calculator, and that equals 21.610 blah blah blah. It says it wants its 2 decimal places, so it will be 21.61. To find the length of the rectangle, what we're going to do is we're going to get the area and we're going to divide it by the width. Now, the question says that it wants the minimum length, so we want the length to be as small as possible. Obviously, to do that, we want the area to be as small as possible. If the area is smaller, the length will be smaller. But let's have a look at a couple of fractions. So let's have a look at a half and 1 over 100. Which one of those fractions is the smallest? Well, it's 1 over 100, but what do you notice about the denominator? That as the denominator gets bigger, the fraction gets smaller. So to make something smaller, we actually want the denominator to be as big as possible. So we want the width to be as large as possible. So we're going to find the lower bound of the area. And an easy way to find a lower bound is find the accuracy. Well, it says the accuracy is to the nearest 10. And what we're going to do is halve that. So half of 10 is 5. And then we're going to take it away from the area. So it's 98,540, take away 5, which will be 98,535. Now for the width, we're going to do the same thing, half the accuracy, half of 10 is 5, but we're looking for the upper bound, we're looking for the biggest it can be. So we're going to add that on, 1, 2, 3, 5. And when you do that calculation, you get the answer of 79.78542 blah blah, and it says it wants it to 4 decimal places. So we're going to do 79.7854. I'm going to start by labeling this triangle, and so I'm going to pick a lowercase a here, uppercase a I mean, for the angle, and then we go opposite it to mark the length with a lowercase a. I'm going to do a capital B here, and then go opposite it to do a lowercase b, and then obviously a capital C here, and then a lowercase c here. Now notice the C's aren't involved in this question at all. It's just the capital A and the lowercase a, and the capital B and the lowercase b. Now when you've got 2 pairs of angles and sides, you're going to be using the sine rule. Now, the sine rule is either sine A over A, or it's A over sine A. Now, when we're looking for a length, we put the length on the top. So it's going to be lowercase a over sine capital A equals lowercase b over sine capital B. Okay, so we're going to fill in the values. So A is x, capital A is 38, lowercase b is 4, and uppercase B is 67. Now you'll only ever sine an angle, so if you ever put a 4 in there or something, that's not going to be right straight away. Okay, let's work out what 4 over sine 67 is, and that's 4.345 blah blah blah. So we're going to solve this. It's It's going to be a nice easy solve today, because all we need to do is times both sides by sine 38. And so that will give us 2.675, blah, blah, blah. And when we round that, we get 2.68. So we first of all need to work out the frequencies in each of the bars. And we know that the frequency density is proportional to the frequency over the class width. So we're just going to go through each of these bars and work out what the frequency is. So all we need to do is times the frequency density by the class width. So 4.8 times 10 is 48. The second one is 0.4 times 10, which would be 4. And then the last one will be 0.8 times 5, which will also be 4. Work out the total frequencies. So it would be 48 plus 4 plus 4, which will be 56. So 56 in total, lines in total, and they only want to see the largest 20%. So we're just going to work out 20% of 56, which we can do, we can just multiply it by 0.2, and that'll give us 11.2. Now you can't have 0.2 of a line, so we can just round that to 11. In this question, it might be easier just to draw a quick diagram. So let's draw this equilateral triangle, and it says that its lengths are all 10 centimeters. And we're looking to find the area. Now, we also know with an equilateral triangle, all the angles are 60 degrees. So we can plot those, but we don't need to plot them all. We can just plot one of them. And we know that to find the area of a triangle, we can use this formula here, which is half AB sine capital C. And if we have a look at this diagram, we can label the sides. So I'll call this side, this angle C, and little c here, and little a here, and little b here. So let's put that into our formula. Little a is 10, little b is 10, and sine c, which is 60. So with a, b and c, it doesn't matter what you label a, b and c, as long as the angle is opposite the side with the same letter. The angles are all capital letters, the lengths are all lowercase. Okay, so let's put that into our calculator, and we get the answer of 43.301, blah, blah, blah. It says it wants it to 2 decimal places, so that is 43.3. So I'm going to, first of all, just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. And that's why it's a nice, easy way to show that A to M is 1/5 of that distance. And let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector b to m, and we know that that's going to be b to a plus a to m. We know b to a because it's labelled, it's just a, and we know a to m because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 a plus 1/5 b. And so a minus 1/5 a is going to be 4/5 a, and then we've got the 1/5 b. So it's going to be 4/5 a plus 1/5 b. So we're going to just quickly write out our sequence, so 9, 22, 41, 66 and 97, and we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19, so they're different already, we know that it's not a linear sequence, and that's going to be plus 31. So we now look at the difference of the differences. And so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence. And we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important, because that is the coefficient of the n squared. So we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence, so what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3, 3 times 2 squared, which will be 12, and then 3 times 3 squared, 27, 3 times 4 squared, 48, 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. To answer this question, we're going to do something a bit weird on the calculator. And this is a method you might not know, but it's the quickest method for answering this question. And what iteration basically is it's feeding the previous solution into the iterative formula to get the next solution, and you keep going and it will get closer and closer to an answer, and then we write down that answer. But on our calculator, what we're going to do is just press the button 1 and then equals. Now what that will do is it will store the 1 that we have here in our calculator. Then we're going to type in the cube root button, and the 1 will disappear. That's not a problem, because the next thing we're going to press is answer plus 10. So on your calculator it should look like this: the cube root, and then answer plus 10. When we press the equals button, what will happen is it will work out what the next number is in our iteration. So if we press equals, we get 2.22398 blah blah blah. Because we're looking for it for 3 decimal places, we're just going to work that out to 3 decimal places. So it would be 2.224. Then all we need to do now is press equals again, because instead of using the 1, it will use the 2.223980091, etc. as the answer. So I'm going to press equals again, and lo and behold, I get 2.304. Press equals again, 2.309 equals again, 2.309. Now, when you get the same answer twice, you can stop. That is our answer. So our solution is 2.309 to 3 decimal places. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.